Hello, my name is Amin, and my partner for this project is Nguyen Tang Fu. For our final Java project, we created a fully interactive flashcard study application built using Java, object-oriented programming concepts, Java FX, file I/O, generics, and recursions, and data structures such as stacks and queues. The purpose of this program is to allow a user to study a set of flashcards, track their performance, and get visual feedback through animations and GUI components. I'm now going to do a quick explanation of the different parts of the program, starting from object-oriented design all the way to stacks and queues. My program includes a clean inheritance hierarchy. The parent class is Flashcard, which represents a study card with a question and an answer, along with the tracking of the number of times seen and number of correct answers, and methods like review and get difficulty score. Flashcard is declared as abstract because different card types may behave differently. I then created two subclasses. One is basic card, which uses a standard question and answer, and a multiple choice card, which has extra features such as a list of answer choices and a parsing method that splits a CSV string into choice options using the vertical bar symbol. Both subclasses override getType, so they can be stored generically and recreated from a file. To demonstrate polymorphism, all flashcards implement the reviewable interface, which defines review and get difficulty score. This allows different types of cards to be treated the same way in the rest of the program. For generics and deck class, I created a generic class called deck, which extends flashcard and reviewable. This class stores a list of flashcards allows adding cards one by one or entire decks and implements iterable. This demonstrates bounded type parameters and wildcard types. This means that I can work with any class that inherits from flashcard and implements reviewable, making the deck reusable and flexible. For file I/O and the repository pattern, all flashcards are stored in a file called deck.csv, which loads data automatically when the program starts. I implemented a repository interface here. Then I built a CSV flashcard repository which reads each line from the CSV file and splits the values into appropriate fields, then reconstructs either a basic card or a multiple choice card, and then handles malformed data through a custom exception called malformed card exception. It then writes program back to the same file using save all. This shows text file parsing, proper try or catch handling, and safe saving of statistical data. For stack queue and recursion, the flashcard uses queue in the form of review queue, which contains all cards waiting to be studied. When the user clicks next, the first card in the queue is removed using the FIFO order. For stack, history stack tracks previously viewed cards. When the user clicks undo, the last card is removed from the stack and moved back to the front of the queue, demonstrating LIFO behavior. For recursion, I created a deck group class that can contain subgroups of decks. It has a recursive function, which I named countCardsRecursive. This traverses all nested groups to count every card, demonstrating meaningful recursion within a tree-like structure. I will now run the code and explain the GUI and animations using JavaFX. The user interface is built using JavaFX, which allows a window with question text and answer text and feedback buttons in the form of correct, incorrect, next, undo, and save, and a status display. When the user presses show answer, I implemented a card flip animation using scale transition and sequential transition. Excuse me. The animation shrinks the answer label to simulate rotation. It swaps the text halfway and then scales it back, giving a smooth visual flip effect. This demonstrates event-driven design, JavaFX transitions, and fluent GUI integration with program state. For exception handling and autosave, the program wraps file I/O in try catch. It notifies the user with JavaFX alert dialogs when errors occur and runs an autosave timer every minute using an anonymous timer task. This prevents data loss and demonstrates correct exception handling and anonymous classes. To summarize, my project successfully integrates advanced Java concepts we learned in class. It integrates object-oriented programming with inheritance, interfaces, encapsulation, and polymorphism, generics with bounding and wildcard types, recursion, queues and stacks, file input and output, exception handling, and anonymous classes, and ending with JavaFX GUI and animation. The result is a clean, user-friendly flashcard study environment that automatically tracks performance, stores data, and provides interactive visual feedback. Thank you.
So hi, this is Win from Group 9, and for our final project we create a flashcard study app that brings together the major Java concept that we learned throughout the semester. So the app lets the user load the flashcard from a CSV file, study them, show the answer, track the correct or the incorrect responses from the user, and allow them to undo a step and save the progresses. We designed the program using object-oriented principle with an abstract flashcard class with two subclasses. First is the basic card and the multiple choice card, and lastly a reviewable interference. So this lets us use the encapsulation, inheritance, and polymorphisms so the GUI can handle different card type in the same way. We also use the Java generic in our deck class with bounds and wildcard type, and we also implement the recursion in our deck group class to count the card across the nested group. So the GUI was built with JavaFX using button, label, and event-driven programming, including Lambda expression and an anonymous class. For input and output, the app reads and saves a deck CSV file and include exception handling for missing or malforming data. We also use a queue to manage the order of card during review and a stack to build the undo feature. And last but not least, we also use AI for debugging to fix issues like missing CSV file, undo behavior that's malfunctioning, and malforming line. Overall, this project helped us understand how all the concept works from this course and fits in full application to create an app. And now, moving on, my partner will be demonstrating the GUI and show you how the program works